All right. Welcome to the to this video right here. So let's take a short period of time. We just reviewing back to the integral that we have done up until this point, and so let's do the integral for the function f of x is equal to x to the power of m, and just the question is what this integral is equal to. So feel free pause the video and try it by yourself. All right, hopefully you have tried that. So let's do this. So f of x, the integration of fx, that means the integration of x to the power of m dx. So that is equal to 1 over m plus 1 times x to the m plus 1 plus c. Okay, um, fairly easy. So what happened is we have been doing integrating only one function, mainly f of x, and I hope you have like fairly get into this type of question already. But sometimes our work is not that easy. Let's try to integrating x times e to the power of x dx. Pause the video and try it by yourself. Okay. All right. So hopefully at this point you have tried it. Don't worry if you couldn't get it. But at least I know that you have tried all your best. And so yeah, so let's start solving this one in here. So if you don't know how to do it, that's very normal, because when you look in this back again, it looks like what? It looks like, well, f of x is like one function f of x, and e to the power of x is like another function. I call it g of x. So this question is actually looks like it's asking you to integrating two functions inside it, mainly f of x times g of x. And that is a little bit frustrating to do it. So today I'm going to introduce you a technique to solve this one. So I think there are more than one technique to solve it, but today one of them I'm going to introduce you for today is something called the integration by parts. Okay, so integration by parts. Okay, so let's start with a question. What is a integration by parts? Now, trust me or not, the integration by parts is actually the idea derived from the chain rule in the differential calculus. So let's try it. Imagine I have a function f of x, g of x, and now all I want you to do is asking you what is the differentiation of this function of this f of x and g of x is. So you use the chain rule, right? So you write f of x, g of x, right, and you differentiating them. So that's equal to f prime times g plus f of x times g prime of x, right? Because that is the chain rule. Now let's try integrating both sides of the function here. Let's try it. So you have this one is f times g of x, the differentiating that, d of x time you integrating this part, g of x dx, and you integrating the remaining part, so f of x times g prime of x dx. All right, so I want you to specifically focus on this part right here. So remember, the first step is you differentiating it first, and then you derive it. You integrate it again. So you differentiate it first, and then you integrate it again. So what you should be getting is the function f of x, g of x itself again. And so in the end, you have the remaining part right here. And trust me or not, this is enough to say this is the formula for the integration by parts. And because I want to follow the textbook, and so that's why I'm going to isolating this part of this equation. I'm going to isolating that. Feel free to if you want, feel free to isolating this part. It's not really a matter at all, but I just really want to follow the textbook. So in the end, I have f of x times g of x g prime of x dx is equal to f of x times g of x minus f of x, f prime of x times g of x dx. And this is the formula for the integration by parts. Okay, now in the textbook, usually they're writing this notation, which is u times dv is equal to uv minus the v times du. If you're familiar with this notation, feel free to go with this. I love this notation that I write above. I learned actually I invented this and then I learned from this one. But if you are familiar with this one, feel free to go with that. And of course, following the following integration by part, the definite integral, it's gonna be, well, this here is gonna be evaluating this f and g in the interval from a to b minus the integration from a to b of x prime of x times g of x dx. Okay, so that is the definite integral. And the condition for this to be true, is that f and g of x are continuous function. Okay, and that is a number one condition. For definite integral, same. So sorry, it would be the same thing, but they have to be continuous on the interval a and b. So I'm going to write that down. On the interval a and b. Okay, because if they are not continuous when you do the integration, you will get divergence. Okay, so a divergent thing will come out. All right, so use this formula that I just boxed in. So I'm going to copy this. Use this formula and solve for the question that I posted on the earlier of this presentation. So let's solve for that. Okay, so solve for x to power e of x dx. Okay, so pause the video if you want. Try by yourself, or you can just continue this video. I'm going to walk you through on how to solve this. So when you look at this formula, you notice that there are four components that you need to find. First, you need to know f of x. Second, you need to know g of x, right? So I'm going to number down g of x. The third, you need to know f prime of x. And the fourth one you need to know is g prime of x. Because there are four components that you need to know. So first thing first, we need to find all these components. So let's write f of x and g prime of x. I'm going to assign f of x is equal to x, g prime of x is equal to e to the power of x. I'll show you what happened if you flip these two around. So what happened if you choose f of x is equal to e to the power of x and g of x is going to be x. I will show you what happened if that if you chose that. But for now, let's go with this flow. Okay, so f prime of x is going to be 1. The derivative of x is going to be 1. And of course, g of x is just integration of e to the power of x, meaning the g prime of x, and that integration just equal to itself, right? E to the power of x. And so let's go g of x is equal to e to the power of x. And that's it. All right, so all what we know, so let's plug in with the formula. So this f is I chosen to be f of x, g prime of x, I chose it to be e to the power of x, right? And I've just followed the formula. So that just equal to f times g. So f is x times g of x is e to the power of x minus the integration of x prime is 1 times gx is e to the power of x dx. Okay, 1 time anything, it's just equal to itself. So that's equal to this. Okay, and so you know that integration of e to the power of x is just equal to e to the power of x, and so that is equal to e to the power of x times e to the power of x minus e to the power of x plus c, and that is the answer for this particular problem. So let me just erasing this. I'm just saying this is problem 1, Okay, so for the particular the problem, this is the answer. Now we'll show you what happened. You flip the two around. So let's say for the same problem, and this time you chose f of x is equal to e to the power of x, g prime of x is equal to x. So let's see what's going to happen here if you flip this two around. All right, so the derivative of f is going to be e to the power of x itself, right? And so g of x is just you integrating from g of x, and you should be getting 1 over 2 times x squared. So g of x is equal to x squared over 2. All right, so use the formula that I show you above right here and just plug them in. Okay, so this equal to f of x times g of x, so meaning e to the power of, so let me just write x to the power of 2 over 2 times e to the power of x minus x prime f prime e to the power of x times g of x to x squared over 2. Okay, and then you notice that not only you get to another like integration with two functions, but you're also getting something weird. That is the x exponential got increased. Okay, trust me or not, if you try the integration by part one more time, you would get uh, something like integrating x to the power of 3 over 6 times e to the power x dx. And if you keep going, you will see that this power exponential will just keep increasing. That's when you know that you couldn't get the right answer. So what I'm recommending is, for particular question, if you try into 3 times of integrating by parts and you're still not getting the final answer, most likely you have switched the f and the g. So just come back and switch them again. This is the way for you to know that okay, you're not on the right track. But if you're getting a 1, a 2, or 3, you after integrating by part 2 or 3 times and you get the final answer, you kind of know that you're on the right track there. Okay, and so for final exam or on the test, I would say maximum 3 times. If it's more than 3 times, probably you're on the wrong track. Okay, because I don't think any professor would be cruel enough to give you a question that had 10 integration by part in there, right? And so let's try a second question. Okay, I did mention that if you try 2 or 3 times integration by part, you get the final answer. That kind of problem-ish. And trust me or not, I want to show you that problem. So when you have to integrating multiple times. So let's try this question out by yourself first and see how it goes. Feel free to pause the video, or else, if not, I will walk you through too. So again, by this point here, I'll choose f of x is equal to x squared itself again, and g of g prime of x, well, I just matching f of x to this one, g prime of x, and matching with sine of x. Okay, all right, and so again, the problem will arise if you switch the f and g around again. But by this point here, feel safe whenever you see a polynomial like x squared, x to the 3, feel free to switch to declare that as f of x. All right, so f prime of x is equal to, well, derivative x squared is equal to 2x, right? And of course, the g of x is meaning you integrating sine of x dx, and sine of x is equal to negative cosine of x. So let's write that. So g of x is equal to a negative cosine of x. All right, so use the formula above right in here, and so we'll solve for this. So this one is actually equal to, well, f of x is x squared, g of x is negative cosine x. Okay, allow me to bring the negative side outside of it. So it's gonna be negative cosine of x. Okay, and then minus, okay, integrating f of x, which is sorry, f prime here should be prime. F prime of x, so f prime of x is going to be 2x, and then g of x is meaning negative cosine of x dx. So allow me to bring the negative sign outside the integration again. So negative and negative become a positive right there. and then I bring the number 2 out too. So number 2 out in the integration sign. So in the end, you have this. Okay, now this time, so this time, it looks like you can do the integration by part again. So let's do it again. So I'm going to choose f of x and then g prime of x again. So f of x is equal to x, g prime of x. So let me just write a little bit closer. It's equal to cosine of x. Now, feel free to call this one h of x and k of x just to differentiate one above. But just want to stick with the formula. That's how I decline that. So I just keep f of x and g of x, so that I just stick with the formula. But if you want to switch to something else, feel free to do that. So the differentiating of f of x in this time here is just equal to 1. So f prime of x is equal to 1. And then g of x, well, g of x is equal to the integral of cosine x dx. Well, integration of cosine x is equal to sine x itself, so sine x. All right, so using the formula, okay, so for this integral, all right, so that's equal to x negative x squared cosine x plus 2. I open a bracket because you just imagine you're doing this integral in a bracket right there, right? So you have f times g of x again, f of x times g of x. So this means sine x times sine x minus, well, integrating of f of x prime, so 1 times sine x, g of x is sine x dx. Okay, so simplifying things, so 1 times sine is just sine itself. Okay, and that what I've simplified into. And so now we know what the integration of sine x is, right? Well, the integration of sine x is just negative cosine x. And so I can writing this one down. So negative cosine x, so meaning I plus cosine x. Okay, I'm adding some random constant c. And so in the end, it just negative x squared cosine x plus 2x sine x. And then, so let me bring the constant c out, plus 2 times cosine x plus c. Yeah, this is pretty much the solution for the this problem right here. So in this problem here, you notice that I have to do 2 times integral by parts in order to derive the answer. Sometimes you have to do 3 times, but I would say in test and final exam, I repeat myself again, maximum 3. If you do more than 3, most likely you're on the wrong track. All right, so let's do one last example, which involving the definite integral, which I did wrote the formula right here. And let's do this last example right here. Oopsie, I shouldn't copy that part right there. So let's me do it again. All right, copy. All right, so let's do the last question, which involving indefinite integral. And this is a very interesting problem too. So question is, the third one, integrating the function sine of x and cosine of x in the interval form 0 to pi by 2. So try to do this one by yourself. Pause the video and try this one by yourself first. And then if you have finished, just continue the video. All right, so hopefully you get a chance to solve it by yourself. And of course, the way to solving this is exactly the same way to solve the previous two. But this one is very interesting as a way that it doesn't matter which one you choose as f of x or g of x, the answer is the same. Okay, I'll show you here why. I'll just show you how too. So I'm gonna choose f of x and g prime of x. So I'm gonna randomly pick f of x as sine of x, g prime of x as cosine of x, and feel free to pick the reverse. Like feel free to pick f of x is cosine and g prime of x is sine, and then just work the math out. Okay, you should be getting the same answer. In this particular problem, you can switch them. Okay, and the other one, be careful with them. All right, the derivative of sine of x give you cosine of x. right? And then integrating cosine of x for sure. When you derive sine to get cosine, that means cosine integrate is gonna be sine x again. Okay. All right. So let's do this integral. Okay. So let me write this one again for a reason, a particular reason right there. So this one is equal to, well, f g, oh, f is sine x, right? G is another sine x, and then integrating from from 0 to pi by 2 minus 0 pi by 2, integrating, well, f, f of x f of x prime, meaning is equal to cosine x, and then g of x is sine x dx. Okay. Now at this point here, you may notice that this one and this one, they are the same, right? So I can bring this part right here to the other, to group them together to the other side so that I can group them together, right? So then I'm going to bring that part to the other side so that that's going to be sine of x cosine of x evaluating from 0 to pi by 2 plus itself again, right? Because they are, both of them are just the same thing, no difference at all. And sine of x times sine of x is sine squared x, evaluating from 0 to pi by 2, right? And so this one itself, adding itself, it's just 2 times whatever it is, so it just cos sine x times cosine x, evaluating from 0 to pi by 2, right? And so this one is sine square of pi by 2 minus sine square of 0. Okay, so sine square of 0, sine of 0 is 0. So this one is go to 0. Sine of pi by 2 is 1, and squared is just equal to 1 itself, right? And so I'm going to keep this part right here. So now you can bring the 2 to the other side. You can divide 2 in both sides like that. And so in the end, you should getting that from 0 to pi by 2 sine x cosine x dx is equal to 1 over 2. Okay, so you arrive the answer solution here by using integration by part. Okay, this one is very interesting problem. So try your best to solve when you switch g of x and f of x around. So just say g of x is cosine and then f of x is f of x is cosine, g of x is actually a 2 prime of x is actually sine, and just switch them around, just solve it by yourself and try it out. And this is the video for the integration by part. Thank you so much for watching. Bye bye.